All right, so now we have a buggy that starts at 200 centimeters and rolls backwards at 25 centimeters a second. We have a second buggy that rolls forward, and we want to know the equation for buggy A. So using the slope-intercept form, we have x equals negative 25 times t plus 200. And for buggy B, we have x equals 15 times t. To figure out when the buggies meet, we're actually going to set these positions equal because they'll meet in the same place at the same time. So we'll get negative 25t equals, sorry this writing's so weird, 15t plus 200. So we'll add 25 to both sides. And so, yeah, I copied this wrong. So for part C, we're going to set this equal. The positions will be set equal to each other because they're meeting at the same place. So we'll set this up as negative 25 times t plus 200 equals 15 times t. We'll add 25t to both sides, and that's going to give us that 200 equals 40 times t. I divide both sides by 40, and I get that the buggies meet after 5 seconds of time goes by. Now let's determine where they meet. So what I'm going to do is I'm going to take this number and plug it back into either one of these equations. I'll plug it back into the B equation. That's 15 times 5, and that's going to give me 75 centimeters. Now, let's just plug it back into the A buggy equation to check that it actually works. That'll be negative 25 times 5 plus 200. And that actually also ends up giving me 75 centimeters as well. Finally, I'm going to go ahead and actually plot these 2 points on the graph, or plot these 2 lines on the graph setup given on the next page. And what we should get is the line should actually cross at 575. So we're going to go ahead and check that now. So let me write down the equations. X equals negative 25t plus 200. And then the other graph is x is going to be 15 times t. So I'm going to go ahead and actually label these graphs. And we'll do that now. So how many squares do I even have here? 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, this is tedious. All right, so here we go. So 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. Oh, how nice. So this is 20 centimeters, 40, 60, 80, 100 centimeters, 120 centimeters, 140. I'm just counting by tens. 160, 180, and 200 centimeters. Yay. Now, let's see. I need 5 seconds worth of time here. So we'll make this 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds worth of time. Sorry, I write those little S's and they look like fives. They're supposed to be seconds. So let's go ahead and actually get these 2 graphs filled in. So if I go over 1 and down 25, I could also do the same by going over 2 and down 50. So I'll go over 2 seconds, so 1 second, 2 seconds, and then down 50, right? Over 2 and down 50. And then over 2 and down 50. And then over 2 and down 50. That looks like a decent line, so hopefully I've got that filled in right. Let's see. Oh, no, down here. Yeah, so I'm going to try to fill this line in. Let me shrink this a little bit. There we go, so we can see that. So we're starting here. This is a really bad sketch, and I should use a ruler for this. Sorry for not doing that. but this is what we get. All right, so that's it. All right, now for the other line, we should go over 1 up 15 or over 2 and up 30. That's the same kind of slope, right? 2 and up 30, right? And that 6 seconds should actually be right there. And then here over 2 and up 30. And if you actually look, they cross at about 575 right there, roughly speaking. So that's a really bad drawing. I'm trying to just get this. This is going to be a bad drawing, but here's the idea. We'll get this connected here. We'll draw this line, and hopefully things work out the way they should. This thing is just not. So this is going to be a very bad drawing, but basically we're going to have this line. We sketch this, and this is roughly, this point here is roughly at 575, exactly what we expected. I'll give you rulers on the test in order to draw these lines, but this really kind of gives us an idea of how to do this last problem on the test, and we'll get a second practice test also on PowerSchool.